All right, how we doing, Tech Lancaster? Ooh, it's been a while since I've been here. We had our 1-year-old's birthday tomorrow, so it's been a busy year. I haven't made it out, but first time at the new venue. Very, very snazzy. Can we get a screen? Oh, no worries. All right, sweet. So how many people are familiar with this meme format or know references? A few of you. All right. Some people get it. Nice. All right. Very nice. All right. So, let's see here. Who here uses JavaScript or TypeScript? Either one. All right. So this should be with a couple people. It should be relevant to some folks here. Very nice. For the TypeScript folks, assuming you understand the configure, have messed with the config at all, how many who have strict mode enabled or know what strict mode is? We got one. All right, we're going to learn some stuff today. Everybody except for Zach. Zach might just know everything. But, all right. So I'll have at the ends, I'll share a link with all my slides and all the demo files and all that kind of stuff. I have a link here if you want to learn more about tsconfig and strict mode in particular. In fact, we can take no, we can't. Let's see if we get hotspot. I don't know. We'll check that out async afterwards. But that's kind of some information on strict mode. Strict mode just kind of, well, for the unfamiliar, I think I'm going to rewind since it seems like there's a lot of people who maybe aren't super familiar with TypeScript. TypeScript is a static typing language built on top of JavaScript, basically. So it adds static typing, and that just means that before you ship code to your customers, you actually see the errors pop up in your compiler, hopefully, right, before they hit any runtime errors. As a cool side too, all my demos today are in Node.js 24, which natively supports TypeScript. So you can just point Node at a .ts file as of 24, and it just works. So let's jump into an example of kind of why. So if you're using TypeScript, you almost always want strict on. I would say it's close to useless with FOSS. I'll kind of hint at why here. So right now it's set to true, but if I jump over, so yes. Let me see. Let me get rid of this terminal. No, do not install. How's that? Or do I need to go larger? I mean, code's never a great thing, but it's all right. So hopefully you can see that. Like I said, if not, I'm sharing all the slides. All these demo files are in a GitHub repo at the end. Let's see. I can deal with this. All right. So as we can see, with strict mode turned on, we take in. Let's say we're getting data from an API. We don't necessarily know that for DB data there. We don't know if there will be users. There could be an error, etc. But it's all optional properties. With strict mode turned on, we kind of get what we want. Like before we ship it to a customer and like we get errors here, we sort of know like, hey, you can't actually reliably access data.users.length because data might not be there, users might not be there. So that's a big part of what strict mode does. It turns on like null checking, undefined checking, all that kind of stuff. If you turn strict mode off, like I said, it's something you definitely, if you're just learning TypeScript or just using it, you almost always just want to turn strict mode on. There's really, I can't think of a great use case not to turn it on. But as you can see, all those help errors just disappear, and TypeScript's like, yeah, this looks good, even though it's definitely not, and will potentially break in 1,000,001 ways. So that's kind of the first thing, is just always make sure you have strict mode turned on in your tsconfig. It's super helpful. Like I said, strict mode is basically, I would say, like 10 TypeScript options all bundled up into one. You set it to true, it just turns on all sorts of different checks. Makes it stricter, as the name implies. But yeah, this is what we want. We want to see these before. So let's see here. And this is kind of, like I said, I'm going to assume, so I'm going to try to, so what we mean by statically typing, dynamically typing too. I'll dive into that a little bit too, because I just think some in the audience here might not know the difference. If you do, actually here, how many people here know the difference between like dynamically typed, statically typed? Good, about half. So I'll dive into it just a little bit, just for some background. So statically typed, for kind of some background, what that means is before I ever even run this code, like it is checking statically. The code doesn't actually have to run. Like it knows that there is going to be an error because these things are possibly undefined. So you can't call the next chain in the method. So what that means is node, it's going to crash. And because I had static typing before I ever even ship this to my users, like I know that, I fix it before I ship it. So like I can see over here, like there might be varying ways to fix this, but you could use, oh man, the giant type's killing me a little, but you could use like optional chaining, and now that's gone, and now that line won't error out. When I send it to users, I could go through and kind of fix each one. So that's kind of the difference between static and dynamic is static catches it like while you're still working on your local machine, and dynamic and this is for the uninitiated too, this is Node.js. This is kind of how you run JavaScript locally in your terminal. So, but let's just pretend this is, like you're sending this code out to users on the web and they're running it on their own browser. So this is kind of what I mean by runtime, is it's going to blow up for your users while they're actually using it. So in general, for especially complex software, I think static typing is great. I think as an industry, we've gone back and forth. Still, dynamic's nice for some stuff, but super good to know ahead of time when you're going to have errors. Let's see. All right, one other tweak that you might want to do, I don't know why it's not included with the default strict mode, but no unchecked index access. For my real nerds out there, does anybody know this setting or ever used it? Zach. All right, Zach's going to be my guy. He's going to be that kid in the class that everybody hates. Is like, yeah. All right, so for the uninitiated, what no unchecked index access does, wow, it's a mouthful. If we go over here, no, maybe it's called, what do I have that in? Oh, index access. There we go. And let's get rid of my terminal. Okay, so really what that means is if you have a function and it can take an array, which is a list, just 0 through infinity for the uninitiated of arrays or lists. If you want to say get the first element, so there's 0 index, so 0 is the first element, it may or may not exist, because like I said, a list could be 0 or hundreds or thousands of items. So basically what turning this on is just let you know that. If you don't have no unchecked index access turned on, it'll just let you call status and, again, blow up for your users. So for anybody new to TypeScript or kind of in control of their own config, whether that's at work or your personal stuff, definitely don't sleep on no unchecked index access. It's a big source of errors I've found. Yes?
I'm curious how comprehensive, like how far back the TypeScript know that you checked it. So like in this case, you've got an argument there to that function. If you only ever call that function with with an argument that has been checked, that there's more than more than 0 elements, and you do this, or do you have to check it in the function?
So you'd have to check it in the function. So we'll get to that later. It's called type narrowing. So like right now, this type is a response or an undefined. To kind of narrow it inside of the function to maybe, this isn't exactly, but we can say, if not, look at that AI helping me out on the fly.
So is there a type that says like this is an array?
Yes, there is a, I think maybe, so there's a what's called a tuple type that says this is an array of 1 to 70, of a fixed known length. So yeah, there's a tuple type. I don't really get into them in here, but yes, there is a tuple type to say that it definitely has a known length and it's never going to be totally empty. But yeah, just definitely a good call for anybody here who is dabbling with TypeScript. Don't forget your unchecked index access. Yes?
Is strict mode instead of TypeScript the same as strict mode instead of Java?
Great question. No, they are separate things, somewhat confusingly, maybe not. Strict mode in JavaScript, I think, man, if I remember correctly, it's been around for so long now, I just kind of assume it's there. It makes it slightly stricter execution environment. I think it might change some stuff around hoisting. I don't know the particulars. I'm not even going to try to answer them, but no, they are not the same. But great question though. They are different things. Interesting observation too, on that note for while we're digging into JavaScript stuff. If you in ES modules, everything's strict mode. There is no non-strict mode, I think. I guess I could be wrong, but Zach's nodding, so I believe that's true. I'm not lying to y'all. That when you're inside of ES modules, everything's strict mode automatically. So let's move forward. All right, so those are kind of settings that you definitely want to use. Next, I'm going to cover a couple things that you might want to avoid. They're kind of there's some caveats I'll go through at the end of when you can use these, but in general, like if you see these like in a PR or you're just learning TypeScript yourself, try to avoid these and kind of learn better patterns to get around them. So non-null assertions. What does that mouthful mean? Essentially, if you can see here, this function takes a user and it takes a name and an email, but email is optional. The non-null assertion basically, let's jump over and I can kind of show it interactively. All right, so what it's doing is it's basically ignoring the compiler. It's the compiler saying like, hey, you don't want to call to uppercase because it might be undefined and that's going to break when your users actually go to run this code. Non-null assertions is kind of a quick, easy way. Sometimes AI will unhelpfully just throw it in there. It'll be like, oh, I see you have TypeScript errors, and throw that thing in there and fix it. It's not a great way to use. The proper way to handle this would be what's called narrowing. So if we go up here, we see that we're actually fixing it. And I can actually, let me do one more thing, actually. So this is with the error in there. You can see it blows up. I don't know if you can read that, but yeah, cannot read fine, trying to do to uppercase. If we properly kind of, eliminate the possibility of calling that, we should go over here and, yep. User John without an email has no email. So, sweet. So that is kind of a feature that you want to avoid, or you want to like yell at your AI, or just tell it not to use non-null assertions if it's fixing TypeScript errors for you. Let's see. Casting is another thing. People from other languages might not exactly know how casting works. In some languages, it might actually do some like coercion at compile or runtime and try to force it into the actual thing. In TypeScript, it's all just a figment of its imagination. It isn't actually doing anything at runtime. It's just telling the compiler like, hey, this is this object, when it really isn't. So if anybody's familiar with JSON parse, it actually returns any, which we'll get into that later. That's another type you want to avoid. But essentially, casting says, regardless of what JSON parse says it is, I'm telling you it has a name and an age. And that's not actually true. Like at runtime, if you try to do something with this, the age property, it's just not going to work. Blow up, actually. Link to for kind of all the ways of narrowing. I'll give you a quick show of kind of why casting is bad. So, and kind of some areas where I see it a lot. So anybody who works in a browser or with like OG DOM stuff, there's the helpful get element by ID. But it might return null if that doesn't actually exist. So let's see if I have this example working. And it blows up. Like instead of going forward to the next line, it stops executing, and it's because it can't actually call click because this is null. And this is because we're casting it. We're saying like, TypeScript, we don't care that it's null. We definitely know, we know better than you that it's an HTML button. And often you or your AI doesn't actually know better. Like TypeScript is actually pretty good at doing flow analysis and figuring out whether something is null or not. And if it does question it, there's better ways than just asserting that it is. So we can do that. Oh, look at this, super helpful for live coding. All right, and so here's kind of one method of narrowing and how we should actually approach this. So if we get our button, we can check if it's an instance of HTML button. And then it actually lets us know like We have a concrete instance of the button, which we know has a click method on it. So that's kind of the, I would say, right way to do it instead of casting with as. Like I said, as doesn't actually, unlike some other languages in TypeScript, it's just kind of telling the compiler, like, you know better, or when you may not.
So TypeScript is smart enough to know that it's inside of the if statement where
Yes.
it's in the if statement.
Yep. Yeah.
A lot of languages, compilers and stuff aren't smart, so I just wanted to.
Yeah. So if you think this is cool, you should check out like OCaml or some of the functional languages. Can really do some wild stuff around this. But it's called flow analysis. So it's basically TypeScript can follow the flow of the code, and it knows, like I can even show here. It knows here it's an HTML element or null. In here, it knows if that condition was true, we 100% have an HTML button element inside of this if statement due to flow and control analysis. Here's another one. So JSON.parse famously returns any, which we'll get into later why any isn't great. And we're just saying like, hey, this is a user that contains a name and an age, but in fact, like pretend we're getting it from an API that may have some optional stuff. It doesn't actually have age. So if we try to run this, it's probably going to blow up, or it should blow up. Yeah. So we can't call toFixed. So age is actually truthfully undefined, even though we told it here it's a number, we were wrong, and it's going to blow up. There's a better way to handle that. So if we go down here, so we can set that to unknown, and then, oh, geez. And do I gotta do that? Oh, actually, let's see. I think I already have this example pre-done instead of doing it on the fly. All right, so this is another, I would say, it's more a verbose way of narrowing. I'm going to show you an even cooler way later on in the slides, but essentially, when you call JSON parse, let's just pretend we're calling an API and we really truly don't know. Unknown is kind of what you'd want to use instead of any. And this is kind of like, it's called narrowing. So you're essentially taking this unknown thing and you're prying into it and figuring out what is actually in there before you go to call it. So we're saying, is it an object? Due to weird historical reasons, this is not null, because null is actually an object, but you can't call methods on it. Fun thing. Is age in there? And is age actually a number? So can we call toFixed and other properties of a number? Can we actually call that successfully without it blowing up? And I think if we do this, oh, it's still broken. 13. Let's see if we can fix this on the fly. Did I just not comment something out? Oh, I didn't save. Let's try it again. There we go. It went through and nothing blew up. Some other areas where I see casting often is in event handlers. If you work with the DOM, again, you don't want to assume your target is an input. It's always better to check that it's an HTML input and it actually has that target and value in there instead of just assuming, because an event can be dispatched and you could really get any object. It doesn't have to be necessarily a HTML element. All right, so let's move on. Yeah, so you kind of saw in that last one, this works for like teasing out one property, but it's kind of verbose and kind of wild. There's lots of libraries that will, at runtime, narrow it and check the type for it. But then it's also smart enough to pass that inference to TypeScript and let TypeScript know that statically before we send it to our users, this is actually what you're going to get. So I can go over a quick example. Let's say we have a user that has a name, age, and email. Instead of kind of 9 or 10 lines of code that is sort of going to tease that apart, like checking if it's null, checking if it's an object, checking if name is in there, checking if name is a string, blah, 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 blah. It gets verbose pretty fast. Isn't the easiest to reuse. So we're just going to pretend that we're getting data from an unknown source, an API. We can't guarantee it's there. essentially what a library, Zod ZOD is another popular library. Valleybot is the one I'm using here, is another pretty nice one, especially for front end stuff where you care about bundle. But anyway, essentially you parse it. You pass your maybe valid data and your schema that was defined above, and you get a result. And then what you can do is you can say, if it's a success, like output is my actual user. And I know TypeScript knows for sure now that this output is good and I can access it and it's not going to break for my users. And if it's else, it will actually like go through and spit out any issues with that user. Let's see here. Yeah, so it parsed successful and logged out this one here. And then for our other user, it failed. If I jump back to the code, we will see one of these guys doesn't have age. Oh man. Let's see. Where's my person without age? Oh, age is wrong. This is the invalid data. So age is actually a string, so kind of calling anything that you think is a number would have blown up. But because we used Valleybot to validate it, we now know before we send it to our users, and we get graceful error handling for that code path. Another feature to avoid is any. I would avoid it at any cost. It's assigned to any type. So it's essentially like a contagious type. Once you have any, regardless of how great the rest of your TypeScript is, it can go in there and break stuff at runtime for users. The alternative is to use unknown instead. Unknown is what will kind of force you to narrow it. TypeScript won't let you access it until you actually pry in there and figure out what's in there safely, in a safe manner. So who here uses ESLint? Nice, all right. So ESLint is a static analysis, so it's kind of like similar to what TypeScript's doing, but it can check other stuff, more advanced stuff. In this case, it's type-aware ESLint, so it can actually take type information and kind of give you some more advanced static analysis on top of that. Who here is familiar with this meme format? Only one. Ah, man, we're not a terminally online group. That's good, though. That's good. All right. All right. So what can type-aware ESLint help with? Promises. Who here knows what promises are? I'm just kind of curious. I like. Nice. Yeah. So it's to work with asynchronous stuff in JavaScript. It kind of makes it easier. It makes it easier. I'm not going to dive in. There's a lot of details there, but what else can we do? We can find where any sneaking in. So before I said you don't want to use any explicitly, but there's lots of sneaky ways any can get into your code base, like JSON.parse. If you use fetch to fetch data from an API, the .json method will return any by default. Unknown is a better alternative, but they didn't have unknown when TypeScript first came out, so they just used any in there. So unfortunately, some of these built-in methods will return any to this day. And then another thing, who here has coded something on the web and seen like object just pop out when you go to use it in a string? Yeah, it can actually catch like most of those kind of object errors or undefined or whatever weird messages that shouldn't be showing up in your UI. So let's jump into some unsafe examples. Okay, so here's a good one. Normally, without ESLint, this would be totally cool. This would be any, and TypeScript would let you call any method in the world you want on data. Here, ESLint is kind of saying like, hey, we have no idea at compile time what is going to be here. So they actually like will force you. They won't let it compile until you set that to a stricter type. They won't let you. They'll only let you basically cast it to unknown. They won't let you cast it to any other type. They'll make you cast it to unknown and then kind of tease it apart to fix that. It also, if you really want to and you try to do an explicit any, it'll also outlaw that and say like, hey, like no explicit any, like just let the type be inferred or use a concrete type here. we really don't want them. What else will it do? Yeah, so it will yell at you if you try to assign, let's see, unsafe assignment. So that's kind of something that TypeScript won't always necessarily catch. If you try to assign an any to another variable, it can kind of, that's where it leaks and can be contagious. If an any does sneak in, this will also catch that. If you try to assign an any to any variable, it will yell at you, whether it's from a function or whether it's your own any of your own introducing. It won't let the contagion spread and will stop it kind of at the source. Let's see, do I have any other? I mean, it does unsafe returns. So if you try to return in any from a function, it won't let you. It says like, you must actually like narrow this thing out and figure out what you're actually returning, so callers know. Just helpful. It's a little annoying probably that you need an extra library on top of TypeScript, because unfortunately any, like I said, is kind of a poisonous type and it's contagious. But I think this is a great, and the setup for this is it's actually super simple to set up nowadays. It's just the default TypeScript type-aware rules. Super easy to set up and incredibly helpful if you're, especially if you're trying to ship robust, solid code. And here is the restricting template literals. So like, it's smart enough to know that this is an object and you can't stringify it. If we actually run this, it would spit out the famous object is not a string, which isn't super helpful. So this kind of would, you would either have to like confirm it's a string and conditionally render like a fallback or something like that. But yeah, just kind of don't want to go too far in the weeds there, but yeah, just suffice to say that for a code base of any complexity or size, this plugin is super handy to help you weed out any stuff. Let's see, what's the other one? Promises. So promises are super cool, but they are very easy to mess up, I think, at least in my opinion. So, I mean, I kind of hint here what's wrong, but I think a lot of people will, the AI is putting that weight there, but that's not actually there yet. So if you call, and this save user is a async function, it's a promise, so like it will go out, do something asynchronously, and return later with the promised value that is in there. If you do not do await, so what we should expect to see here is, well, let's run it and see what we get, and then kind of what we would expect. So node. So this is saying it's successfully submitted, but I know that I hard-coded save user just always throws. And the reason that's happening is because we forgot an await. So what this is called, it's called a floating promise. It just kind of is literally floating, like it doesn't, it escapes control flow, essentially. That's one of the, I'll get to another point that's bad about floating promises. But yeah, essentially you always want to await, return, or if you truly do want kind of a floating-like promise, you can call .then and .catch to keep it confined in there, but it still won't, it won't leak up to your global error handler, which is what I'm going to talk about next.
Can you use the void keyword too?
Yeah, you can use void, I think is another, it'll tell you, I think it might. Yeah, yep, explicitly marked with void. So you can use void, await, return, or explicitly like handle it right there with a .then or .catch. Let's see. All right, for anybody who here has like instrumented their front end or node or anything, and like you just get a ton of unhandled promise rejections filling up your instrumentation. That's from floating promises. So what happens also is because we didn't catch this here, it actually, regardless of how many layers and function calls we have above this, it just floats the whole way up to the global error handler and will kind of pollute that and can make it difficult to find the source of errors. So yeah, definitely a cool feature to be able to catch floating promises before you send them out to users. You can kind of catch this all at compile time with the mix of TypeScript and ESLints. Let's see here. What? Oh, let me put an await and see if this actually does what we want now. So we should probably not see that successfully submitted because it should. Yeah, so it doesn't, we don't see the successfully submitted, and we gracefully handle the error. It's not hitting our global error handler anymore, which is what you generally want. You want to kind of have, in general, for most errors, if they're kind of within the realm of expectation, you want to handle them as locally as possible and not let them float the whole way up to the top of the application. Let's see here. All right, so who here works with like a big JavaScript code base that's a little messy and gnarly to work with? Like anybody? Yeah, so this applies to a couple people. So here are some kind of tips and standards for how to gradually introduce TypeScript if you already have a big JavaScript code base. I'd say the easiest way is to start with leaf nodes. So if you kind of think of your module tree as a graph, go to the tips of that graph. There's usually less code. It's importing less code. It's just a lot easier to go out and transfer it. This is the one time where I would consider giving folks a grace period and kind of letting them cast or use non-null assertions. You're still moving towards more static-friendly code. If it's too overwhelming, you can still stick, or the AI will stick some of those dirty but sometimes useful when you're first converting or learning TypeScript stuff in there. Yeah, and if you really have, yes.
I'm surprised that you offered that advice. I feel like my intuition would have been to like, you have a JS code base that you want to convert to TypeScript, and you start like at the trunk and gradually propagate it out to the leaves. Because if you do it the way you just suggested, then aren't you constantly casting stuff so that it can make its way into your already converted?
So the issue is it's very, if you start at the trunk, it's very hard because it's contagious. So if you start at the trunk, you might be importing 27 modules, and because they're in untyped JavaScript, they're all returning any. So it's very useless. Versus if you start at the leaf, you can actually like convert that whole thing, and it can be, you know, quote 100% sound, as sound as you can get in TypeScript, and it does, because it's importing very minimal because it's at that leaf thing. And then it's I would say that's not, I don't know if that's true. I just know I've converted like several, like going on three now, big code bases to TypeScript, and that's always, wasn't always. I learned it along the way painfully, but that's definitely one of the easier ways. Yeah, if you have a particularly gnarly file and you just really want a couple sections of it, again, these should be used super sparingly, but you can kind of go in and disable ESLint. Just be very specific, disable like a single line and the exact thing you want to actually disable within ESLint. Sometimes like, you know, if you're new to TypeScript, or it's particularly dynamic or kind of just in general bad sort of squirrely code, it can be super hard to statically type retroactively, and you might not want to refactor it then and there, but you want all the code around it to be sound. So it's a good use case. And you can also, if it's a TypeScript error, you can just use a TS-expect error and kind of explain your logic of why you're expecting this error to be there. You know, I can't statically type this. Yes?
I didn't hear you said it, but are you able to convert any back into like a number or a string and make sure that's a safe operation?
So I'm not sure, but so am I able to convert?
So let's say you have a string and somehow that string turns into any, are you able to turn that
Back into a string?
Yeah, but do it safely.
Yes, yep, yeah. So yeah, that would be called narrowing. I think I can maybe show a quick example on the fly. So let's see here. Const a string, colon n equals. So this is we kind of know it's a string, but I purposely just casted it to any. So one way would be like if type of string equals string, and then kind of inside of here, we now know that a string is a string because of flow analysis. So that would be kind of like one way. If somehow it ends up as any, you can use type of or the narrowing I discussed earlier to tease that back out. I think that's maybe what you're asking. And if not, I can pair up afterwards and kind of work through that. Yeah, and another cool thing, how many people know this meme? Anybody? Oh man, not many. Am I old or just? All right, all right. Yes, all right, this is a few of us. All right. Yeah, so another thing kind of when you're converting an existing type code base is you don't actually have to do like the full, well, there's two good reasons. Maybe you just don't even want to transpile. You just want to ship JS, but you still want to have types. You can actually put types in JavaScript now. Not what I was showing you earlier where you're running TS in Node. This is actually just checking .js files. So you just got to add a check.js true to your TS config. And that will check all the JS files in your code base. Or, like I said, if you want to incrementally attack this, you can just add a allow JS true and then do a /@tscheck comment at the top of your JS file. And that will opt that file into, and TypeScript will do its best to go through that JS file and find type errors for you. And I won't go into it here, but if you go to the type docs, JS doc comments, if you're familiar with them, that's kind of how the types work. And you can do almost anything. It's just a little bit more verbose and cumbersome, I think. Yes? Yes, great question. So I think, let's see, I might, no, not yet. I thought I might have an example file for this. So there is, so that would be in here, and you would have allow.js, and then, so this would be in your TS config, so your main compiler config. It's either going to be this configuration JSON, or like if you're running it from the CLI, it would be a long list of CLI arguments, or how to configure TypeScript. And then inside of, I think, maybe, yeah. Yeah, so like, as you can see, this has a is property, but I'm calling it as TypeScript running in here, and it won't let me compile or ship this, even though it's just plain JavaScript, because I have this TS check. Or like I said, if I use the other compiler option, I can check all files. So kind of super helpful. And this is very simple, but just kind of like how you would type params. So if I wanted to type this function parameter, I can just call it a string, and TypeScript actually like knows it's a string, and when callers call it, assuming they're in TypeScript, it will not let you pass a not string in, and it will, provide and let you safely call all the string methods on there. All right.
JS doc is great for common things, and like even
Yeah.
super helpful. Definitely look it up.
Yeah. Yeah. I can even show like a quick example. So I think if I put it above some info about this function, and then yeah, right here. So I mean, it seems stupid here, but say you have like 600 people importing this function, anywhere they are in their IDE, they can hover over it and they can see some info about this function. They can see the signature. So yeah, JS doc is definitely super handy I mean, I think it's supported in most IDEs now. I mean, this is VS Code fork, but pretty much everything supports JS doc and the TypeScript comments. Yes?
TypeScript JavaScript, but there's no runtime checking effect. It's all bolted on like that.
Sort of. TypeScript understands JavaScript's runtime type checking. So that's how some of that narrowing works. When you do if type of, where did we do that last? We did that somewhere. So TypeScript understands, this is actual JavaScript. Like at runtime, JavaScript is literally like checking, like say, hey, V8, is this a string actually a string? It will definitely be a string in here. But TypeScript understands that check, so it can also statically like infer inside of this if. I know before we even get to runtime, if this check is true, I know with 100% certainty that that's a string. So it's kind of both, I would say. TypeScript is definitely bolted on JavaScript, but it understands the semantics and stuff like that. Another interesting thing about TypeScript is it's called a type erase language. So it actually, outside of some weird edge cases, in general, it actually has zero effect on your runtime, generally speaking. It just strips away the types and sends plain JS to the browser. It exists entirely to help you catch errors before you ship code. Yes?
Is there a can you you give us an example of an error that you were able to catch that you probably would never have seen with JavaScript, but because of TypeScript you have?
Oh yeah. So I work at a company called New Relic. We do observability. So that's like instrumentation, basically. Like if your server has errors or performance issues, et cetera, et cetera. Anyway, I work on the logging team, and previous members of the team assume that there would always be a date and that it would always be a string coming back on our logs, but that's not actually true in our logging pipeline. There's various ways that property cannot be there. It's only for a small handful of customers, but our telemetry was so noisy and it just kind of always fell underneath the rug. And when we converted to TypeScript, we actually had a customer reach out and say like, oh, for some reason this page always crashed for me. I just, they went around it and found another page that didn't and achieved the same functionality. But like we actually caught that from TypeScript. Floating promises are actually a huge one. So like I talked to earlier, we had tons of unhandled promise exception, and they're kind of hard. They don't always trace back to a line number, especially with compiled JavaScript or minified compiled. So we eliminated tons of them just through static analysis of like it finding like, hey, this is a floating promise. Either handle it here or attach an explicit .catch to do something if we have an error there. So yeah, I would say a lot. I found just a couple weeks ago in one of our tests, we converted a test to TypeScript, and they weren't asserting correctly, and it actually always asserted true, whether the test is passing or failing. But TypeScript kind of found that bug, and when we fixed it, it would actually fail if the test was bad. So yeah, I mean, there's definitely been several cases of users testing, helping clean up our telemetry that TypeScript's been super useful.
One last question?
Yes.
Sorry, repeat your question. How does this compare to something a little bit more loose like type linting in Python?
Oh man, I'm not an expert in type linting in Python.
Site linting will not catch these. It is for you to look at, and if you can still say, hey, send this as a string, but you can actually still send it in as a number. And so you will run into a lot of the same errors because it doesn't actually check the types.
But the thing is just you already. Okay.
Yeah. So I think the closest Python has that I know of is Python, which will go ahead and take where you can basically say, hey, this object should, if we want to take in like a JSON object, it needs to have a string, a number, like name, age, and is active true or false as a boolean. And it will actually check that boolean. But for functions, I don't think it ever actually checks that. And I don't know how, I forget how, or I haven't looked too much into basic Python to actually explain how you could even avoid floating promises or if we have the same issue.
Yeah.
Similar problem though, because you still have like a dynamic, interpreted language versus like static,
Yeah.
compilation.
Yeah.
TypeScript.
I think
Running.
I think one key difference is and again, I don't know this for certainty, but I think Pythons might be able to actually integrate with the runtime a little bit. JavaScript, due to the nature of like, it's super hard. You can't just change a browser's JavaScript implementation. That's why it's a type erased. Like it literally just strips all the types out. Like I said, I don't know this for sure, but I imagine Python could like probably maybe utilize that type information in the runtime. Yes.
Most of the typing in Python can be seamlessly left in, so there's no compile out step.
Yep.
The few newer constructs have been added real recently that don't work in super old versions of Python anymore. But if you're using typing from 3 years ago will work on Python like 10 years ago.
Yeah.
It just won't actually type check it.
Yeah, that makes sense. Nice. See? I mean, if anybody has any questions or wants to chat about anything, you can hit me up here or on Slack or leave a comment on my GitHub repo. I think the slides are in there.
We can also get the slides posted on Slack too, so.
Yeah, I can even do that. I'll post the slides on Slack too. They're in the repo now, but I can post them in there. They're in PDF format too. Sweet.